Hello, boys and girls. We are going to be working together to make our way through Module 4, Lesson 4 of Eureka Math for 2nd grade. So before we get started, I want you to make sure that you have a sharpened pencil, that you have your blue math book with the 4-5 on the front, and that you are finding page 25. I also want to remind you that if you need to slow this video down, if you need to pause it, if you need to back it up and rewatch part of it, you are more than welcome to do that to ensure that you are staying with me as I guide you through this lesson. So let's dive in. Our focus here is we're going to not be adding, but we want to focus on subtracting multiples of 10 and some ones within 100. That is going to be our focus as we continue through this subtraction unit. So here is the paper that you should have in front of you. This page right here would be page 25 with page 26 on the back of it. So let's zoom our focus in to look at problem A. We are given the equation of 23 minus 9. Now, we could solve this. 23 is larger than 9, meaning we can actually subtract it. But we would have to regroup because 3 ones is less than 9. So we would have to take a 10 apart and break it into ones. To avoid having to do that, what we can do is change this subtrahend of 9 into a zero-ending number so that when we subtract it from our minuend, we don't have to regroup. So let's give it a try. Thinking back to when we did this with addition, we're doing a similar idea. We are going to try to get this subtrahend to a zero-ending number. So when I think about the number 9, I know that my next multiple of 10 is actually 10. And to get there, I would need one more. So I'm going to think about 1 plus 9 will equal 10. Now, I have to be fair. Whatever I do to the 9, I have to do to the 23. So I'm going to add 1 right there, which now brings me to 24. And you can actually see that they've given us this equation, 24 minus 10. So let's stack that up and solve it. So 24 minus 10. And remember, you have to make sure that you've lined up your ones with your ones, your tens with your tens. But now we're ready to subtract. So 4 minus 0 is going to equal 4. 2 minus 1 would equal 1. So 24 minus 10 equals 14. So that means that we should be able to subtract 23 minus 9 to find the difference of 14. But let's go ahead and give it a try. So I'm going to stack up and align 23 minus 9. And when I think about those 3 ones, I do not have enough to subtract 9 ones. So I'm going to go over here thinking about these 2 tens, and I'm going to take one of those tens, and I'm not going to just get rid of it, but I'm going to break it into 10 ones. So now, no longer do I have 2 tens, but I have 1 10. I went down by 1, which means over here I've gone up by 10, and you can see I added those 10 ones. So now this number is not but 3, but 13. Well, now I can subtract the 9, and when I do that, I am left with 4 ones, and then this 1 10 stands by itself. I'm not subtracting anything. I could even put a 0 there if I needed that placeholder, but 1 minus 0 equals 1. Using both strategies, the strategy of being able to get it to a zero-ending number to subtract got me the difference of 14, and when I did it that good standard algorithm way, I also found 14 to be the answer. So it does not matter which way you use, you should get the same answer as long as you do it correctly. But today, as we work on learning this strategy, I want you to do both ways for practice. So let's move our focus to problem B. We have 32 as our minuend, and we are subtracting 19, which is our subtrahend, and we are looking to find what is the difference or the answer to a subtraction problem. So I'm going to go ahead and stack or put my 32 in my larger part of my tape diagram because it is my greater number, my minuend that I'm going to be subtracting from. Then I'm going to look at 19, which is my subtrahend, and I'm going to put it in the smaller part. Now, again, I want to get that to a multiple of 10 or a zero ending number. So if I think about going from 19 to my next zero ending number, which would be 20, I would need one more. Now if I add 1 to the 19, I have to add 1 to the 32. So now this is not 19, but 20. And this is no longer 32, but 33. So now I could rewrite my equation from 32 minus 19 to become 33 minus 20. Well, when I stack that up to subtract, I find that 3 minus 0 equals 3. And 3 minus 2 would leave me with 1. So the difference of 33 and 20 is 13. But let's try it using the original equation to see if I get the same answer. So stacking and aligning 32 minus 19. I look at those two ones and I recognize that I cannot subtract 9 ones. So I'm going to think about the 3 tens that are over here, and I'm going to go down by one of them. So now I'm left with 2, but it can't just disappear. It has to reappear in my 1. So I went down by 1. I'm going to go up by 10 over here. So adding back those 10 ones, I now am left with 12 ones. Well, I could subtract 9 of them and find that I am left with 3. Moving over to my tens, I have 2 currently. If I take 1 away, I have 1 10 remaining. So I got the same answer or difference when I subtracted. 33 minus 20 equals 13. 32 minus 19 equals 13. Good job, guys. All right, let's look at the bottom of this page. We're almost done. Now here you can start to see we're kind of being let go of trying to make this on our own. So we are not given the tape diagram to fill out. We have to create it on our own. So we are given the equation of 50 minus 29. Now, 50 is a zero ending number, but it is not the number that we need to be a zero ending number. We need this subtrahend of 29 to be a zero ending number. The number that we are subtracting needs to be a zero ending number. So I'm going to think about that number 50 being my whole, and I'm going to think about that number 29 being the part that I am subtracting. Well, if I count up 29, 30, that is my next multiple of 10 or zero ending number, and I needed one more to get there. Well, that means if I add 1 here, I am required to add 1 there. So this is no longer 50, but 51, and no longer 29, but 30. So my equation has morphed from 50 to minus 29 into 51 minus 30. And if we align that to solve, 1 minus 0 equals 1. 5 minus 3 equals 2. If I go back to my original equation to attempt to solve, I have 50 minus 29, and I look at having 0 ones trying to subtract 9 ones, and I can't do it. So I'm going to go down by 1, up by 10. So now 10 minus 9 equals 1. 4 minus 2 equals 2. Both equations gave me the same difference, so my answer to these equations is 21. One more. So 47 minus 28 is my next equation. So if I think about 47 being that whole that I'm trying to subtract 28 from, I know that I need 28 to get to a zero ending number. So if I count up 28, 29, 30, I need to add 2 to get there. Well, what I do to one, I have to do to the other. So 47 is no longer 47, but has transformed into being 49. So my new equation has shifted from being 47 minus 28 to being 2 more, which means it is now 49 minus 30. If I stack that up, making sure to align my 1s and 10s, 9 minus 0 equals 9. 4 minus 3 equals 1. Let's give it a try at that original equation. 47 minus 28. Those 7 ones will not allow me to subtract 8 ones, so I've got to regroup. And so in order to do that, I'm going to go down by 1, up by 10. Now I have 17 ones that I can subtract 8 from. 17 minus 8 leaves me with 9 ones. And then moving over to my 10s, I have 3 10s that I'm going to subtract 2 10s from, and that will leave me with 1 10. So my difference here is 19, and I got that same answer doing it both ways. Right, turn your paper over. You are actually given addition problems here, and that is not our focus. So we are just going to put a small, thin X on this page, and we are going to move on to our next